The cross at the edge of the board, called a fiducial mark, is used by the vision system to set a local frame of reference for each printed circuit board. By comparing this reading with that of an ideal board held in a database, it recognizes any variation, either in the board itself or in the way that it's been fed to the assembly point. Then, by calculating the difference between the orientation and layout of each individual board with the positions of the master board held in memory, it generates offsets that slightly change the path of the arm, so compensating for any variation. We can see this by deliberately moving a board. The camera rereads its position and the system makes its calculations. Then the arm continues to mount components, taking the change of position into account. Without this sort of flexibility, modern surface mount technology would be impossible.
When you manufacture electronic printed circuit boards and when you're mounting components on those printed circuit boards, the sizes are such that you cannot program a machine to accurately put down components onto those boards without first getting some information off those boards.
In commercial production, quality of output and speed of assembly are paramount. At IBM's Greenock plant in Scotland, they assemble boards with over 1,000 components. Typically, each component is 2 to 3 millimeters in length and must be placed within a tolerance of 0.2 of a millimeter. Information is read off the boards using the same fiducial marks that we saw at Loughborough. Here, though, it's the workboard holder that moves, positioning itself to receive each component. So the offsets calculated from the fiducial marks are fed into the mechanism that drives the bed. But the principle is the same. Sensing, lending intelligence to a system so that it can deal with uncertainty.